Assalamualaikum and hi everyone. We are from Group 2 and our statistic project title is the size of SISKOR uniform in UTHM. This is our group member. First, Shazawani, next Nik Shazwan Najiha, then Fatihatul Ainur, next Umi Mazatul Akma, and the last one is Nur Fatin Zahira.
Abstract. As a part of this project, we intend to explore and analyze the size of the SISKOR uniforms at University Tun Hussein of Malaysia, UTHM. SISKOR, standing for Sukarelawan Siswa or Siswi Correctional, represents a distinctive uniform worn by individuals associated with a specific program or department within the university. The research methodology involves a comprehensive survey and targeting a representative sample of individuals who wear the SISKOM uniform. The outcomes of this research project are expected to contribute valuable insights to the optimization of the SISKOR uniform sizing process. The current sizing of SISKOR uniforms will be systematically evaluated through anthropometric measurements and surveys among the UTHM community. This comprehensive data collection will enable us to identify areas of improvement in the existing sizing structure, taking into consideration the diverse body shapes and size of individuals within the university.
Next, introduction. Statistics is a major discipline of study that focuses on data gathering, analysis, interpretation, presentation, and organization. It is critical for comprehending and making sense of the massive quantity of information that surround us in a variety of sectors, including science, economic, social science, and healthcare. In academic research and institutional studies, understanding a certain group features and demographic is critical for making educated decisions and planning strategies. This introduction digs into the data size analysis of Sukarelawan Siswa-Siswi Correctional, SISKOR. This study seeks to investigate the characteristic and experience of SISKOR members, offering insight on their motivation, problem, and the effect of their voluntary activity. As we progress through the data size analysis, we want to uncover pattern and insight that go beyond the surface, providing a complete picture of the SISKOR community at UTHM. Next, methodology. The current case studies methodology seeks to provide a full understanding of numerous variables linked to the efficacy of the data size SISKOR uniform of UTHM students. Our target participant in collecting data in UTHM students who are actively involved in Sukarelawan SISKOR Siswa-Siswi Correctional. A diverse sample across various faculties and academics level will be sought to ensure a representative data set. Then we will do data collection, which is we will be given a survey question. A systematic survey question will be created to gather information on student SISKOR uniform size. The question will be contain height, weight, and uniform specific dimensions. The survey will be distributed online and good electronic facilities to ensure that the data taken is answered honestly and transparently. So this is data size SISKOR uniform of UTHM student, which is we collecting for 100 people only. This is our data set.
Result and discussion for Chapter 1, Random Variables. Refer to Table 1, find mean and standard deviation of the distribution of student SISKOR size uniform. From the table we can find mean equal sum x equal 38 multiply 3 over 20 plus 40 multiply 1 over 5 plus 42 multiply 7 over 50 plus 44 multiply 21 over 100 plus 46 multiply 3 over 25 plus 48 multiply 1 over 10 plus 50 multiply 2 over 25 equal to 43.14. Standard deviation square root sum x square minus sum x square. For sum x square equal 38 square multiply 3 over 20 plus 40 square multiply 1 over 5 plus 42 square multiply 7 over 50 plus 44 square multiply 21 over 100 plus 46 square multiply 3 over 25 plus 48 square of multiply 1 over 10 plus 50 square multiply 2 over 25 equal 21C.C plus 320 plus 246.96 plus 406.56 plus 253.92 plus 230.4 plus 200 equal to 1874.44. Standard deviation square root 1874.44 minus 43.14 square equal 3.579.
Binomial normal distribution. Find probability of a student randomly selected, chosen, size 42. P equals to number of people with size 42 over total number of people. So it equals 15 over 100 equal 1.15. Find probability of 5 students that choose size 42, which is n equals to 100, x binomial x 0.15, when p equals to 0.15, so q equals 1 minus p, so q is 0.85. Probability of 42 is equals to nqx, p power of x multiply with q power of n minus x. So 100 C5 times 0.15 power of 5 times 0.85 power of 100 minus 5 equals to 0.0011. Then find mean and standard deviation of this binomial distribution. Mean equals to n multiplied with p, so 100 multiplied with 0.15, that results 50. When standard deviation equals to square root of npq, so square root 100 times 0.15 times 0.85, that results 3.571. Lastly, find probability that at least 10 out of 14 randomly selected students choose size 42. So z equals x minus mean over standard deviation equals 100 minus 15 over 3.571 equals to 0.3803. So probability of 2.3803 was taken from table distribution, results 0.00866. Poisson normal distribution. Suppose the SISKOR uniform fee was collected from 100 students within 4 months. On average, 5 students completely pay for the uniform fee in the first week. Find the mean of the Poisson distribution in this scenario. Find the exact probability that 20 students complete the fee where students are size 40. Use the normal approximation. Find the probability at least 10 completely pay for the uniform fee for the second week. So, mean is equals to 5. Probability of 20 students calculated by formula exponent power of 5 times 5 power of 20 over 20 factorial. It equals to 0.0058. Then, find z equal x minus mean over standard deviation. Standard deviation equals to power root of mean. So, power root of 5 equals 2.236. Z equals 10 minus 5 over 2.236, so equals 2.2361. So probability of at least 10 completely pay for the uniform fee is 0.01287.
For Chapter 3, Sibling Distribution. At the SISKOR Club, the mean size of the SISKOR uniform of the student is 3.14 and the standard deviation is 3.0579. A random sample of 100 students, SISKOR was collected. What is the probability that the average size of the student uniform of the student is less than 40? Mean for 3.14, standard deviation 3.6579 over square root 100 equals 0.36579. Sn for 3.14, 0.36572 equal P as less than 14. P Z less than 40 over 43.14 over 0.1338 equal P 0.00939.
From table 1, 21 students choose uniform in size 44. Table 2 shows students size 44 complete the uniform fee in 10 weeks. Construct a 90% confidence interval, single mean, for the mean number of students that successfully pay the uniform fee. N equals 21, which is less than 30. Standard deviation is unknown. 1 minus alpha equals 0.9. Finding alpha, alpha equals 0.1. Alpha over 2 equals 0.05. Finding V equals N minus 1. So 21 minus 1 equals to 20. Mean of the data is 5.667. Standard deviation is equals to 82.7789 over 20 equals to 4.139. Mean plus minus T alpha over 2V multiply with standard deviation over square root of N. By referring table distribution, T 0.0520 is equal to 1.725. Then multiply with 4.139 over square root of 21. Mean 5.667 plus minus 1.558. The final answer is 4.109 less than mean less than 7.225.
Next, chapter 5. In a survey, a sample size of 100 students was chosen randomly. This survey claims that the average number of students SISKOR size uniform is 43.14. Assume a population standard deviation of 3.6579. Does this seem to indicate that the mean number of students has a size uniform greater than 38? We use 1% level of significance. The right tail test 2 to H1 mean larger than 38 is known. The sample size more than 30 and the alpha equal to 0.01. Case A is used, normal distribution. Z critical equal to 2.33 and Z test equal to 14.0518. That's mean Z test more than Z critical. Since Z equal to 14.0518 larger than 2.33, the dedication is to reject the null hypothesis. There is enough evidence to support the claim that the size of the student's SISKOR uniform is significant.
For Chapter 6, Simple Linear Regression. The following data represents the number of students who complete the uniform fee in 4 weeks X and the corresponding numbers of students who complete the uniform fee in 4 months. Why? Fit at least squares line that will enable us to predict the numbers of students completing the fee in 4 months. Why? In terms of the number of students completing the fee in 4 weeks. X. Interpret the result. Sum of X equal to 27. Sum of Y equal to 100. Sum of XX equal to 230. Sum of YY equal to 2608. And equal of XY is 682. For N is equal to 4. Sum of XY equal to 7. Sum of XX equal to 47.75. Next, for B initial, we will use the formula B initial equal to sum of XY divided by sum of XX, and we will get 0.1466. For B0, we will use the formula Y minus B initial X, and we will get 24.7435. For Y equal to B initial minus B0X, we will get Y equal to 24.7435 minus 0.1466x. When the number of students completing the fee in 4 weeks increased by 1%, the number of students completing the fee in 4 months will also increase 40%. So Y equal to 24.7435 minus 0.1466x. X we can assume as 40. So the final answer we will get 30.6075, and we can assume it as 31. In conclusion, the statistical report covers various subjects, including random variables, probability distributions, sampling distributions, estimation, hypothesis testing, and basic linear regressions. It provides a comprehensive understanding of statistical techniques and their application in various sectors. The study emphasized the practical application of these methods in various sectors, emphasizing the importance of statistical literacy in data-driven decision-making. The knowledge gained from the study serves as a toolkit for analysts, decision-makers, and researchers, helping them handle the complexity of data analysis and inference. That is all for our presentation. Thank you very much.